Macrophages are a type of white blood cell, or leukocyte, whose varying functions, also known as a phenotype, are crucial for wound repair. There are three primary stages of wound healing: the inflammatory phase, the proliferative phase, and the remodeling phase. The inflammatory phase begins immediately after an injury. During this phase, monocytes leave the blood and enter damaged tissue where they mature into macrophages. Macrophages can also proliferate from a local pool of other macrophages. During the inflammatory and early proliferative phase, macrophages adopt a pro-inflammatory phenotype, sometimes called M1, and release pro-inflammatory cytokines and other growth factors that support tissue growth. These macrophages may then participate in phagocytosis of pathogens and dead tissue, initiate the formation of blood vessels, also called angiogenesis, and recruit fibroblasts for collagen deposition. However, during the late proliferative phase and early remodeling phase, macrophages transition to an anti-inflammatory phenotype, sometimes called M2. During these phases, macrophages decrease the release of pro-inflammatory cytokines and increase the release of anti-inflammatory cytokines and growth factors that support deposition of new tissue. Confining macrophages into M1 and M2 phenotypes, however, is an oversimplification. These phenotypes exist along a spectrum and can be expressed simultaneously within a healing wound. Macrophage phenotypes can also become dysregulated, leading to chronic inflammation and impaired healing. Chronic inflammation consists of a sustained buildup of neutrophils and macrophages, particularly those with pro-inflammatory phenotypes. Ultimately, the macrophage must be finely regulated in space and time to promote healing through its pro- and anti-inflammatory phenotypes.